Okay, so this was the problem that we were working on. Does everybody still have enough light to take notes this way? Because I know you can see the screen better that way. Okay, so what we have done so far with this problem, just a quick review to get your brain back where it was, is we went through and read the problem. They gave us this table about two kinds of bolts that we're manufacturing, which we call type 1 X and type 2 was Y. And we decided that, first of all, it didn't make sense to make a negative number of either one, so we went ahead and wrote those two restrictions. Then we made an equation for each one of the three machines by knowing how much time it takes to make bolt number 1 and how much time it takes to make bolt number 2 on each of those three machines. And we came up with the maximum amount of minutes that we had available to work on those machines. And what we want to do is maximize revenue. And our revenue equation says that type 1 bolts sell for 15 cents and type 2 bolts sell for 20 cents. So that's how we came up with this revenue equation. So we graphed the set of inequalities. And we determined that the feasible region for that set of inequalities is this green region right here. And that's called the feasible region, and we said that it was bounded because it has a boundary around all four edges. If the feasible region had turned out to be this area out here, for example, all this way, then that's an unbounded feasible region. And you can have one or the other. So then after we did that, we needed to find the corner points. And the corner points are all of the points where the boundaries intersect. And since one of the corner points was the origin, that was easy to find. This corner point happened to be a y-intercept, so that wasn't hard to find. This one happened to be an x-intercept, so it wasn't hard to find. But this one and this one, we had to find the intersection of the pink and the blue line for this one and the green and the blue line for this one. So what we did was we went back and found the equations for those, and we put those equations together in a matrix, and we used the reduced row echelon form of that matrix to find the solution. And the solution for the pink and the blue turned out to be 1050, 450, which is right here. And then we looked for the blue equation and the green equation. Which was this one and this one. So we put them together and we found the reduced row echelon form of their matrix, found the solution to be 500, 1000. So this corner point was 500, 1000. And even though I recorded them here, I came back to the first page and made a list of them, because what we're going to need to do is we need to actually maximize these, and I'm going to actually start that process all over again. So let me again make a note of what the corner points were, so we can go back and make sure that we know what we're doing here. So our corner points are all X and Y. So our corner points, we didn't put down 0, 0 because obviously you're not going to maximize anything if you put in x equals 0 and y equals 0. But we have 0, 1250, 1200, 0, and then the two that we found just by using the matrices, which was 1050, 450, and 500, 1000. And we want, excuse me, we want to maximize the profit function. And the profit function was z equals 0.15x because type 1 bolts sell for 15 cents each, and 0.20y because type 2 bolts sell for 20 cents each. So that takes us to where we were when we left off. So we're going to use the calculator. And we're going to calculate for each of those points what the maximum revenue is going to be by substituting in these values into this function. So with the first z, we're going to have 0.15 times 0 plus 0.20 times 1250. And since we can do the 0 part in our head, I'm going to do the 0.20 times 1250. And that comes out to be $250.
So would you keep it in dollars instead?
Well, the equation is in cents, but what it actually comes out to be is $250 because we took care of the cents by using 0.15. Okay? If we hadn't used the 0.15 for the cents, and we had left out the decimal saying 20 cents, then we would have gotten 25,000 cents, which is $250. Okay? So then the next thing we're going to plug in is we're going to plug in, using this corner point, z equals 0.15 times 1200 plus 0.20 times 0. And that gives us $180. So that's definitely not a maximum point. We can tell right now that that's not going to be a maximum. So then we move on to the next one. And we have 1050, 450. So that's going to be z is equal to 0.15 times 1050 plus 0.20 times 450. So 0.15 times 1050 plus 0.20 times 450 is $247.50. And comparing 247.50 to 250, that's not the maximum either. So we only have one more point to check out. So the last one that we're going to check out is 500, 1,000. So that means we're going to plug in Z equals 15 cents times 500 plus 20 cents times 1,000. And that gives us $275. And since 275 is more than 250, then this gives us the maximum. And that's the way you should write your answer. You need to interpret your answer. Yes?
Why is the last equation different from the rest? There's parentheses over.
Because I left out a set of parentheses.
Oh, okay, got it, all right.
Yeah, thank you. And when I put it in the calculator, I didn't use parentheses, I just used multiplication symbol, because it works either way. Okay? So actually, this wraps up everything that you learned in chapter 1, which was how to graph lines, and in chapter 2, which was how to find the solution of two equations by using matrices. And now in chapter 3, we're learning how to apply it to something realistic in business, like maximizing profit or minimizing cost or some other function. Okay? So that's going to be the whole goal for your next test. Does everybody have their notes for chapter 3, section 3?
Yeah, we answered part B, but we really have to do on the test.
Let me go back to the original problem again. Says, okay, we did answer part B. What is the maximum revenue? The maximum revenue was $275. And the answer to part A was 500 type 1 and 1,000 type 2. And then it says, suppose that selling price of type 1 began to increase. Beyond what amount would this price have to increase before a different number of each type of bolts should be produced to maximize revenue? We can work that out, but I'm not going to ask you a question like that, because honestly, working it out using the methods that we have in chapter 3 is long and tedious and difficult.
Yeah, this
And-
one sounds tedious and
Yes, it's very, very tedious, and if we were going on into chapter 4, which is linear programming using the simplex method, it would be easy to answer that question. But in this chapter, it's difficult to answer that question. It takes a lot of juggling. So we're not going to ask a question like that, and we're not going to answer that part of it. Okay? The reason I picked this problem to do was I knew I could leave that out, but this is a really good problem to illustrate all the different things that you have to do. So let's go to the notes, and now we should be able actually to work through quite a few really good problems. I've got one, two, I think 2 examples here, maybe more, let's see. Now that's section 1, so we've actually, for this section, we've only got 2 problems. And even though I brought up the PowerPoint, I don't know that we need it because it just works through those 2 problems. And rather than deal with the PowerPoint, I think we'll just go ahead and do these problems from scratch by hand, one at a time, so that y'all can keep up better. So for our next example, we have a problem about renting canoes. And our example says that Thomas Pinedo plans to start a new business called River Explorers that will rent canoes and kayaks to people to travel 10 miles down the Clarion River in Cook Forest State Park. And he has $45,000 to purchase the boats. He can buy the canoes for $600 each and the kayaks for $750 each. He has a facility that can hold up to 65 boats total. The canoes will rent for $25 a day and the kayaks will rent for $30 a day. How many canoes and how many kayaks should he buy to earn the most revenue if all the boats can be rented every day? So we need to break this down. First of all, like we had in the last problem, does it make any sense if X represents canoes and Y represents kayaks? Does it make any sense whatsoever for X or Y, either one, to be negative? No. So we want to go ahead and start off by saying our first restrictions are that X and Y should both be positive, which means when I draw my graph, what I should do drawing my graph is just not even include anything but the first quadrant. That way I don't have to worry about doing any shading. At least not for that pair. So we'll start the equation, start it out where we only work in the first quadrant. And this is going to be canoes. And this is going to be kayaks. And they both start at the origin, which is 0, 0. And we've taken care of that part of the restriction. So then we go on to read some more. One thing about these kind of problems is you're going to have to read them all at least twice, maybe 3 times, to get your information picked out. So he has $45,000 to purchase boats. That means that the most boats that he can buy is going to depend upon how much they cost, the total cost. So what we need to know is, given that he has $45,000 to spend, how much can he spend on them if he's buying canoes and kayaks? And in order to figure that part out, we go back and look again, and it says he can buy canoes for $600 each. That means that's going to be 600x. And it says that the kayaks are $750 each, so they're more expensive. And at the most money he has to spend is $45,000. So that gives us another one of our restrictions. 600x plus 750y is equal to or less than $45,000. So then we go back and say, okay, now he's restricted also on how many boats. How many boats can he buy? He only has a place that he can have as many as 65 boats. So the total number of boats that he can have can't be more than 65. So the number of canoes plus the number of kayaks can't be more than 65. So that is x plus y is equal to or less than 65. And then we're going to turn to the money side of things. This is not a constraint. It says the canoes will rent for $25 a day. Kayaks will rent for $30 a day. How many of each should he buy to make the most revenue? So that's going to be our objective function. That's what we call the objective function. And the objective function in this case is 25x plus 30y, with the $25 a day for canoes and the $30 a day for kayaks. And he wants to maximize that, so we're going to call it z. We're going to look for the largest possible value of z. So that's what's called the objective function, and these are what we call constraints. And the constraints are what we have to graph. We're going to need to graph the constraints.
So, when I have a graph like that, I don't have a problem pulling information out. It's when we're doing like our homework problems on my lab, that it just gives you the word problem, and then I get stuck as to what my constraints are. Because it doesn't, I have trouble when it doesn't start it for me, and I have to do everything.
Because they don't give you the table.
Right.
Okay, let me pull up a MyMathLab problem when we finish this one, and we'll work through it, and I'll show you how to figure out how to set up your table. And I will tell you on the test, I usually set the table up for you because I know that makes it easier.
Okay.
Okay? Let's finish this one up, and then we'll do a MyMathLab problem. Or actually, what we could do, I think one of these other problems, we could just kind of ignore the table
Okay.
and figure it out without going to the table. But it's easier if they give you the table, it really is. Okay, so what we need to do to finish this problem, we've already taken care of these two constraints. So what we need to think about now is how are we going to graph this so that we can fit everything on here? And the easiest way to do that is to go ahead and find your x and y intercepts for both equations. So for 600x plus 150y, oh, so I'm sorry, 750y. We're going to find the boundary line where it's equal to $45,000. So if I let x be 0, y is going to be $45,000 divided by 750. In other words, if I bought only kayaks, what's the most number of kayaks I could buy? And then on the other hand, I'm going to let the 750 be 0 and find out how many canoes I could buy if I didn't buy anything but canoes. So for y is equal to 0, then I would have 600x, and let's just start out with x over here and divide the 600 into the $45,000. So that's going to give me 2 points. So if he buys only kayaks, he can buy 60. If he buys only canoes, he can buy 75. So this first point is 0, 60, and the second point is 75, 0. Okay? So that means I need to scale this in such a way that I can go as high as 60 in this direction and as high as 75 in this direction. But just in case that the other equation gives me something I need different numbers, and it's not going to because it's only a total of 65, then I'll go ahead and get the other corner point, the other 2 points too. So looking at this function, if I let x be 0, then y is going to be 65. So that's the point 0, 65. If I let y be 0, then x is going to be 65. So let me do a little counting here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I've got 14 spaces. So that means I could go as high as 75 if I can imagine that that's what's up there. So let's say this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So 75 would be all the way up there, and I don't actually need to go that high. So my first point is going to be 0, 60, 10, 20, 30, 40, 50, 60's right there. And then the other point that I need is 75, 0, 10, 20, 30, 40, 50, 60, 70, and 75 would be about there. And that would be a solid line because it's equal to or less than. So there's my blue line. And then for the pink line, I need the point 065. And I need the point 650. So there's my two lines. And then the next thing that I need to do is I need to actually decide what point is going to work. So I'm going to plug in 0, 0. So if this is 0 and this is 0, is 0 equal to or less than $45,000? And yes, of course it is. So I'm going to shade toward the origin. And then is 0 plus 0 less than 65? Yes, it is. So there again, I'm going to shade toward the origin. And when I shade toward the origin, and this is the region that's the feasible region. Excuse me? Right. I'm actually shading below both lines. Try to think of it as above and below. So there's my feasible region. And I already have some of the corner points. This is one of the corner points, 060. This is one of the corner points, 650. And the only one that I don't have then is where they cross. I need that one. So in order to find that one, I'm going to come back up here, take my two constraints, and their boundaries, and form a matrix. And then I'm going to use the reduced row echelon form of that matrix to find this point. So matrix A needs to be a 2 by 3, which it is. And its elements are 1, 1, 65, 600, 750, 45,000. And I'm going to print out matrix A to make sure it looks like it should. So 1,165 and 600, 750 and 45,000. Then I'm going to go back to matrix, over to the math button, and go down to B, step B, which is RREF. So this is matrix A. And RREF for matrix A is 1025 and 0140. And this corresponds to 1x plus no y's is equal to 25. And this corresponds to no x's plus 1y is equal to 40. Which then gives me my corner point, 25, 40. So there's the list of all my corner points. And my objective function is that 25x plus 30y. So again, I'll go to the calculator. 25x would be 25 times 25. And 30y will be 30 times 40. And that gives me $1,825. If I use the point 060, I have 25 times 0 plus 30 times 60, and that gives me 1,800. And then if I use 65 0, it gives me 1625. Now before we go any further, does anybody have any questions so far? Everybody knows where everything came from. Okay, so then at this point, looking for a different color. not finding it, so. Since we want to maximize this quantity, the maximum possible value comes from that corner point, 2540. And it gives us $1,825 in revenue. Okay? So here's our complete problem. And the question says, how many canoes and how many kayaks should he buy to earn the most revenue if all the boats can be rented every day?
So 25 canoes and 40 kayaks.
He should buy 25 canoes and 40 kayaks. Now, it didn't ask us, but if it asked us what would his maximum revenue be, then we would come down here and look at this number and say his maximum revenue would be $1,825. Okay? Any questions?
Could you show me the revenue part of the graph and like of the table? Up there, like, what they produce and the products and the totals. Would you fill that in?
With this,
Yeah.
I would fill it in because it makes it easier to do your objective functions. And the question that Janice was asking is, you know, what if they don't give me the table? How am I supposed to figure this out? So we're gonna go to my math lab now because I've got another example, but honestly, I can make a little recording and post it in Shelby for you of this other example.
And that 1825, is that maximum revenue per day?
Yeah, that's his maximum revenue per day because it says each day.
Okay.
So what I want to do now, and I will go and post the other one in Shelby for you so that you'll have it to refer to. But let's go where you don't have all this wonderful information and you got to do this all on your own. As soon as I find a plain white piece of paper. There we go. And since I'm going to need a piece of graph paper, let me go ahead and print one. Actually, let me print a couple in case we were to need another one. Does everybody have graph paper, or would you like me to post that for you so you can print it out from DQL? Okay, I'll put it in D2L. There may already be one there, but this one actually is a lot better graph paper because it's kind of big and easy to read. So let's go and pick out a problem.
There's one on milk.
Milk,
Yeah, that is about dairy and milk, that's really different.
okay, good to know. Let's go to assignments. In 3.3,
It's, well, it's, they had it both in the review and it's the same problem,
okay.
but in the review, there's more to it.
Okay, well, let's go to the review. We're talking about the review quiz, right?
Right.
Okay. That's almonds. This one?
Yes.
Okay. So this one says, I'm going to pull my graph paper off to the side so I can make notes about the problem, and then we'll go to the graph. It says a dairy company gets milk from 2 dairies and blends the milk to get the desired amount of butterfat. Milk from dairy 1 costs $2.40 a gallon. I'm going to make some notes here. So I would write that down. And then it says milk from dairy 2 costs 80 cents a gallon. Must be some fancy cows on that first dairy. Says they have at most $144 to purchase the milk. Dairy 1 can supply at most 50 gallons. And it averages 3.7% butterfat. Dairy 2 can supply at most 90 gallons. And its milk averages 2.9% butterfat. And it wants us to answer parts A and B. And part A says, of course, how much milk should each supplier should the company buy to get at most 100 gallons of milk. I just wrote down the desired amount is 100 gallons at most, with the maximum amount of butterfat. And then it says how much, it gives us two blanks to fill in for how much they're gonna buy and how much is the maximum butter fat. And then solution from part A leaves both dairy 1 and 2 with excess capacity. Calculate the amount of additional milk each dairy could produce. Is there any way this could all be used while still meeting the other constraints? So let's see. We've got all the information we need. Let's see what we can do about solving this thing. Because the main thing here is to translate. Okay. We have two dairies. The quantity from each dairy is the unknown. Okay? So the first thing we're going to do up here at the very beginning of this problem is say X equals number of gallons from dairy 1. And Y is going to be the number of gallons from dairy 2. We may not be able to answer all these questions, but I'll at least get you set up with it, and then I'll add this problem to the recording of the other one. So milk from dairy 1 costs $2.40 per gallon. You're going to have one equation that's going to be the amount they buy. The amount of milk. You're going to have one equation that's going to talk about how much does that milk cost. And that's dollars. So looking at the rest of the problem, come down here to the bottom and it says their desired amount is they want to buy at most 100 gallons of milk. So that tells you that the amount of milk they buy from dairy 1, which is X, plus the amount of milk they can buy from dairy 2, which is Y, must be equal to or less than 100. So we've taken care of that part. Part 2 is about how much money they've got to spend. Their cost.
So it'd be 2.4x
Exactly.
plus 0.8y is less than or equal to 100.
Right. So that takes care of the cost and the total amount they have to buy it. So now we've used up that part of the information. Now we have some other constraints. I think it's fairly obvious from every problem that we've done that X has to be greater than 0. And Y has to be equal to or greater than 0, or they're not buying anything. They can't buy negative amounts of milk. But it also says down here that the dairy can only produce that much milk. So dairy 1, it has to be more than 0, but it also has to be less than or equal to 50. And dairy 2 has to be less than or equal to 90. Now the easier way to write both of these is 0 is equal to or less than X is equal to or less than 50. In other words, X has to be between 0 and 50. That's a shorter way to write this. And it's also a way that makes more sense to you. And then y has to be between 0 and 90. The lowest it can be is 0, but the highest it can be is 90. So that's another constraint. So we've used up this information now. We have one more piece of information. And it focuses around what it is that they want. They want the maximum possible butterfat. So we want to maximize the butterfat. And Dairy 1's butterfat is 3.7%, so that's 0.037 times X. And Dairy 2 is 2.9%, so that's plus 0.029. Y is equal to Z, which is our objective function. And the reason it's called the objective function is because the objective of the problem is to get the most you can.
I feel like this is just finding that and
Everything
everything else is pretty simple after that.
else after that probably is pretty
I
simple.
don't have problems after.
It's
that.
the setting it up. Yeah, I understand. That's the hard part. And this is the way that I actually do these when I do them. Is I actually will, as I go through the problem, I'll read through it all the way first time. Then I'll go back one sentence at a time and say, okay, what does this tell me that I might need to know?
Is there anything like within a problem that you could revise to say, hey, like I can pick through and find, the equations, but what would be something that would give you an idea that would be some function? Is there a keyword or anything like that? Do you know if you figured out would be the very last question that would point to that being the objective function?
Let's go back to the problem and see how we can answer that. Until you actually come down to the question, what is the maximum amount of butterfat, there's nothing that's going to tell you what the objective function is. It is, I think you were on to something though, usually it comes at the end of the problem. The objective function comes at the end. All of your constraints come from everything before that. Now they did give us, no, in this one they didn't give us any extraneous information, but sometimes they'll give you an extra piece of information that has nothing to do with anything. And that's why I suggest you read through the problem first and just kind of for yourself say, what's this problem about? I mean, is it about the amount of milk? Well, somewhat. Is it about the amount of butterfat? Yes, it's about that too. But everything in the problem is relating back to something about milk.
I guess the best thing of this is like, okay, the prices, there's a price constraint in there,
Yes.
but there's nothing that says, well, this is the total amount of butterfat you got. We don't know that.
We just, yeah, if they don't give you a total amount of butterfat, then that's a big clue that that's what you're gonna wanna maximize. Or if it's a shipping problem and it says this warehouse can hold this many and this warehouse can hold this many, and this is the most they have of this particular item, this is the most they have of this particular item, and shipping from warehouse 1 costs this much and shipping from warehouse 2 costs this much, and then they don't ever tell you what the total amount that they want to spend on cost is, you're going to say, well, logically, the least I can spend on shipping means the more money I'm going to have left over, so that would be your objective function. So really,
Oh, sorry.
no, that's okay, go ahead
If
and
I
answer.
was solving this myself, what I would messed up on was the at most 50 gallons and the at most 90 gallons as a constraint. I would have tried to put that into another equation instead of just say X has to be less than or equal to 50, and Y has to be less than or equal to.
Okay, the way that you would tell the difference in that, this one says this is the most they can supply. And it tells you that this is the most the other one can supply, but if you were gonna put it in an equation, it would say the most amount of milk they can store is this much, which means the amount from dairy one plus the amount from dairy two cannot be more than, or is
So
equal to.
because they put at most 50
Yeah.
and separately listed at most 90, that should have been my clue, that those were my signs for
Yeah.
less than.
Less than or equal to. It says at most, it's always less than or equal to. If it says at least, greater than or equal to.
Okay.
Okay? So I will finish this problem up for you because I know it's getting really, really close to time. It's like 10:21, so we're actually out of time. I'll finish this one up for you along with the other one. If you see others that you would like to work, all you have to do is send me a message in Shovie or send me an email or click Ask My Instructor, and I will be more than happy to work whatever you need me to work. Here are your exams as you go. Be sure to show all your work and answer in complete sentences, please. And I'll be back to you later.
And did you say you would
Many of the sheets that I got, that I printed out, and I will also put some in Shovie. So I'll have these pictures for anybody that wants to take them, but I will put some, not in Shovie, I'll put them in DTL so you can print them. In fact, I may just email it to you as an attachment,
Okay.
because that way either way you can print it. Okay, who did not get a test? Okay. I'll tell you that I didn't get stapled. Okay? Everybody's got a test, right? You too. You too. If you have any questions, just let me know. Okay. You too.